Today we're going to be talking about what we've done at GoDaddy to operationalize basically 19 years worth of infrastructure, specifically using MySQL-as-a-Service. So a little bit about me. My name is Nathan Northcutt. I'm a senior software developer for GoDaddy's MySQL group. That's probably about as interesting as it gets. But for those of you that don't have a lot of time, we'll give kind of an overview of the presentation in 3 slides. So one, I'm thrilled to be here. Thank you everybody for showing up. There's a lot of work that's gone into this. Our team is very excited to kind of share some of what we've been doing. And so to kind of kick things off, you may find yourself in a situation like this where your infrastructure and your processes don't necessarily meet the business needs that you've got anymore. Sometimes it's pretty obvious like here. Sometimes it's a little more subtle. And especially when we start talking about infrastructure and operations, the immediate go-to is just kind of let's automate the process. And the one thing that you've got to keep in mind is that, especially with 20 years of infrastructure, if you try and automate a complicated process, you're likely to get something that looks like this. And while it does do everything in a very set pattern, it may not be exactly what you want. So as we go through this today, I'm going to kind of talk a little bit about what DevOps is like at GoDaddy, kind of how we've approached this problem, separating out, this is what we do on our day-to-day jobs versus what's kind of the business value that we're offering going forward. We're going to be talking about how we've approached this problem, taking a look at containerization. We're going to be taking a look at how we make sure that this isn't just a greenfield initiative. It's one thing to build out a brand new service platform that everybody's going to use, but if it doesn't leverage 20 years worth of investment and time, that's not necessarily the best use of our time. And then we're also going to be talking about what we've done to kind of build up our services as a set of kind of blocks so that we can remove some of that complexity. And barring some time, we'll be taking a look at some of the early impacts that we've seen. And for questions, I will be outside afterwards. I'll also be at the networking events tonight. Please come talk to me about anything, whether it's high level, you want to get into some more of the technical details. I'm more than happy to do that. So getting started, we're going to take a look we started our process by taking a look at what we did and then what we need to be doing to scale with the business going forward. So DevOps at GoDaddy is a lot like this. We have tens of millions of customers that are using our systems every day. That could be for WordPress, that can be for hosting. Some of those are internal applications. To give an idea of some of the scale that we're dealing with, we have about 6.5 million databases that spread across more than 15,000 instances globally. And that's growing every day. And so to kind of prevent everything from going to chaos, we have our friend here. And a friend often is seen as a policeman, but really our friend here is the DevOps team that we have. And it's about 8 people right now. So if you consider that, that's roughly about 750,000 databases that I could be responsible for at any given point in time. And a lot of this, because it's grown up over several years, there's a lot of things that feel kind of tribal in knowledge. There's things that we're doing that we don't necessarily understand. They're not up front. And we've got, because we're a ticket-based system right now, that can become a choke point. So anytime you want to get a backup or restore, create new, instance provisioning, you have to enter a ticket, and then somebody from our team's got to go pick that up, actually go handle that. And that can be very exhausting for the team. We've even got points now where we have, 1 week on-call rotations where somebody's dedicated to doing nothing but that while everybody else is trying to keep the lights on. And so a lot of that comes from we have a very complicated infrastructure. So again, as you would imagine, over 20 years, we've got a mix of operating systems, MySQL versions, both major and minor. We've got hardware that scales a large period of time. And then that's not even taking into account the application-specific complexities, configurations, topologies that we have to deal with. So when we were talking about this, we kind of came to the conclusion very quickly, you can't just automate your way out of this problem. There's too many edge cases and too many one-offs to really handle. So what we did is we said, all right, let's look at kind of the value proposition that we've got for the business. What are the things that we have to do well to be able to scale with and kind of grow GoDaddy's customer base and keep everyone happy? So as we go around this kind of in a clockwise fashion, some things are pretty obvious. We need to be able to handle provisioning. I should be able to create or delete instances for you in a very quick manner. I also should be able to track kind of our capacity and utilization, both as a system as well as kind of what you've used up. We also need to be managing configurations. Not all of our application users, especially not all of our end users, the actual customers. This is a lot of, mom and pop shops, small and medium-sized businesses. They're not SQL experts. So it's kind of our job to work with how do we configure the system to get you the best performance. That's something that we feel like we should own. We also should be maintaining a level of availability for you. It's no use to have a database if it's not up. And so for us, we need to keep something at least of 4 nines obviously we'd love to go higher than that. And whether that's trying to do something with infrastructure, setting up the correct topologies, master, multi-master, master-slave, trying to set up clusters, that's something that we should be helping to kind of manage for our business to move forwards. Having just that availability isn't great if your data is not consistent. So one of the other things that we need to manage is kind of that backup and restore cycle. How do we make sure that in the event of a catastrophic failure, we don't have to say, hey, I'm sorry, everything's gone. It's not a good conversation to have with anyone. Since we maintain the infrastructure, we're also in charge of maintaining host updates, making sure that you've got the latest security updates, making sure that you've got the latest firmware, things like that. There's also things with just the MySQL versions. There's always different minor versions that are coming at us. There's new tweaks, bug fixes, things like that. We need to make sure that you're running on the latest and greatest, and also to help you to kind of move your application forward. When you want to go, say, from 5.6 to 5.7 or 5.7 to 8.0, we're here to help you with that. And then kind of at the end of this is we need to be able to give some sort of capacity monitoring metrics so that you know how much of your system you're using. I can't possibly know about every application that's running on our data plane. It's too large. But what I can do is start giving you some information about how your system is being used so that we can start having a conversation and you can see, hey, I made a change and my CPU just spiked. That's probably not a good thing. So this is kind of our value proposition. If we do these things well, GoDaddy will run at a much greater scale. And on top of that, when we're looking at trying to figure out what are we doing for our new platform, we wanted to keep a couple of other things in mind. So one, we want everything, whether it's our users or our DevOps, we want that all going through an API. That kind of helps remove some of the pressure that we've got on a ticketing system. That doesn't really scale so well. It also kind of helps out with this. I don't have to know necessarily how everything happens. I just have to know how to ask our APIs how to do it. That kind of makes it a lot easier to onboard new people. With this, we have to make sure that we're going to scale with the business. We can't be having this conversation again in 18 months because we just had a spike in growth. So whatever we're doing, we need to make sure that we're anticipating kind of the future. One of the main things, especially for me in this, is that this can't just be greenfield. We can't just say, hey, look, that 20 years of stuff, everybody keep supporting it, everybody move over to this latest and greatest. That's not practical, and that doesn't work on a timeline for us that is acceptable. So whatever we're doing has to support legacy infrastructure. On top of that, we want to make sure as we're growing, we're becoming a more global company, we need to make sure that we're ensuring a level of fault tolerance. As we start scaling out, we can't have something that is impacting in, say, Phoenix, blocking somebody that is over in Europe. We need to make sure that we're trying to remove as many places where we have single points of failure as possible. And last, we want to make sure that we're trying to keep things updated in a timely fashion. For our sake, we'd like to do this aspirationally on a weekly basis so that all of our environment stays a little more homogeneous. We have much less variance in what we're having to deal with at any point in time. So kind of knowing that and knowing what we're looking for, we said, okay, cool. How do we want to build this system? And so the first place that we started is kind of with the capacity. That's the easiest place. Where are these databases going to live? And we basically came up with kind of 3 pretty normal choices here. The first is we can just take and spin up a bunch of MySQL instances, support it out of the box. I don't have to do anything special outside of some potentially outrageous configuration, but we could do it. Now the problem with that is that there's really no resource isolation. It's really easy for user 1 to completely cripple user 2 simply because they gobbled up all of the resources on the machine. So okay, we say resource contention, that's maybe a problem. Well, VMs, those are an excellent way to isolate down resources. That will definitely work. We can do something a la Trove. The problem that we found with that is that the number of instances we were talking about spinning up on individual boxes, there's some concern that we're not necessarily utilizing our hardware to the best of its capabilities. We're giving up an awful lot to the hypervisor and the multiple kernels that we're trying to run. So we said, okay, resource isolation, let's go ahead and take a look at containers. That's kind of a natural piece that's coming up. That gives us the resource isolation that we want. We don't have the overhead of all of these virtual machines that are running. The only worry that we've really got is everything's on a shared kernel. If it pops, everybody's dead. But there are very few instances in our case where we have to actually worry about that. And we could easily cover 99% or more of our infrastructure just by going down the container route. So that's kind of where we settled. So just as a real quick thing, how many people here are familiar with containers? So, okay, a lot. Awesome. This is going to be good. So for those of you that aren't, this is a really, really high-level kind of version of a container. We're going to talk through it really quick. Just as an FYI, we're using Docker. There's nothing specific that Docker is doing here that you couldn't do with something like Kubernetes or another system. It just happened to kind of fit with what we were looking at in our experience. So if we look at this slide from the top down, at the very top, these are our system resources. These are the things that the application actually needs access to. I need network, I need CPU, I need RAM, I need access to the file system. And the part that actually is constraining all of that, no matter what containerization you're using for the most part, it's going to be something like namespaces and C groups. Those are enforced by the kernel so that when your application is running, you can't take too many cycles on a CPU. You can't access more than X amount of RAM. We can also do some stuff with the overlay file system because we're using Docker. I'll get back to that one here in a second. But then kind of down here at the very bottom, we have this idea of a container. And so for the way that Docker sets everything up, containers are based off of images. And images are just, you can conceive of it as a set of overlays that are built up on top of each other to give you a set of functionality. Now some of these can be as simple as, here's a bash command that I want you to run, it executes, it's done, that runs within a container. Some of them, like the ones that we're using, are much more complex. So we start out, for us, with a CentOS base image. So we start with Cent7. We layer some of our own stuff on top of it. Some things are obvious, like MySQL. I need that to run. That's kind of useful. We also put things like Percona extra backup on there. We've got a bunch of tools and utilities that we've built up over the years that we would also like embedded in there just to keep our operational experience kind of the same. And the one main point that we found with Docker that was kind of an interesting piece is that Docker can really only run one process at a time. So if you just said, I want to host MySQL, it could run MySQL, but it's very difficult to get anything else going. We have some additional monitoring things that we want to have within that container, so that doesn't really work out. But what we did is we did some customization so that we can run initd. So basically, we get very much like a VM Lite. So I can actually SSH into that thing. I can execute different commands on it. I can run in a much more ops-friendly way without having to worry about the fact that I'm actually inside of a container. Now, one of the other nice things that we found is this overlay file system. Now, this thing becomes really, really fun because if an image is just a standard set of bits that everybody starts with, this allows me to separate the data from the actual MySQL process itself. And so this overlay file system allows you to say that when Docker first spins something up, it creates just a loop file that it mounts. And that's where all of your data is fed from. And so if you just spun up a container and ran it without doing anything, your data would be there until the container was gone, and then your volume gets popped, all of your data is gone. That would be problematic. What this overlay file system allows us to do is say, take something like a directory, varlib MySQL, and actually redirect that out to a different place on the host. Say varlib dbaz, some sort of identifier for that instance. Everything that MySQL inside of the container is doing is for varlib MySQL, and it's completely oblivious to the fact that we've redirected that out. We can also do that with individual files. So when we want to inject configuration files to make sure that everything is consistent, we can just use one configuration file and keep using that in different containers. We don't have to worry about config drift at that point. And so there are a lot of things that come out of this that are really nice. Some of the main things is we don't have a heterogeneous environment anymore. Like, it's very, very homogeneous. We may have multiple images, but I know every single container that was created from this image looks identical. The other nice thing is that when I look at two different instances that are running, I can really define this as the difference between the data that you're running and the resource constraints that I've given you access to. How much RAM does this one have? That's really the main difference between them. That assumption also allows us to say that we can look at an instance as a tuple of a network route to get to the data, and then the data itself. I don't have to worry about any of the rest of that. That's something that we'll come back to again in a second too. But the really cool thing is that if the containers are truly isolated, trying to figure out how we're doing allocations on a host becomes simple bin packing. There are a lot of algorithms and ways to deal with that. And then if you start looking at it as a network route and some data that I have to match up, that again is a problem that's been solved by a variety of different languages and techniques. We can actually leverage a lot of that information to build our system. We're not having to create things from scratch. And so a majority of our system is built off of this one piece that we believe we've achieved, which is if I have a network route and I have your data, I can keep your instance running wherever I want. Those are the two things that I have to control. And so to give you an example, we can walk through kind of how we would do provisioning. So over here we've got our user. We've got a set of services that we expose out. We have a routing layer that we're maintaining. We've got a set of capacity that's back here. This can be allocated in whatever way we want. We can fence this in by network zones, data centers, regionality, applications, whatever we want. It's completely opaque to the user. And so when a user makes a request, comes into our services, we go ahead and validate you haven't violated any of your quotas. We go and make sure that we've got all of the pieces of information that we need to go ahead and assign you to a host. We can build out a container on that host. Once we've figured out that everything is up and running, we can notify our routing network. So this routing now knows your instance, where it actually lives right now, and we can keep that up to date. And we return that information back to the user. So the user can have this DNS entry in a port. Still don't know where they're going. This gives them an entry point into our routing network, and we can reverse proxy them into the correct active instance in our system. So this allows us to do things like rapid failover. This allows us to kind of break the contract that we've had before of capacity is allocated to a specific team. And allows us a lot of flexibility. And the other piece is we are always making sure that we're taking DR backups and moving that to a persistent store. And what I mean by that is not another physical host. That would be something like Ceph or another distributed application, so that if I blow up a specific box, your data still survives that. And that's really what we're looking for to maintain that availability and durability. So that kind of works for us. But this still hasn't addressed what we're doing with legacy. This is great going new, but how does this help us in our previous infrastructure? Well, when we take a look at this, generally speaking, our users connect to a specific server that they've got access to, and they may or may not have a port. So what we do is we notify our network layer, our routing layer, that we would like them to redirect this user to their existing instance. We don't actually move their data at all. The only thing that we're trying to do is break that hard and fast rule so that we can say, okay, cool, I want to get the first part established. This is a network route. Once that's done, it's now broken. I'm free to actually start doing more interesting things. And I can use the same tooling that we're doing in these containers to, things like extra backup and some of these other utilities, to actually move this data back into our persistent storage. Now this, even though we do have this wide variety of operating systems and things, this is the only place where we actually have to engage with that complexity in our environment. This is something that is achievable. Once we've got this in place, we can spin up a new container, restore your data into it. We can go ahead and slave that up, make sure that there's no issues, make sure that everything is running correctly, get you brought back up to date, and then it's a simple notification to our proxy layer that we'd like to start rerouting you into our DBAS infrastructure. Now the nice thing here is we've only had to do two simple operations. One, update your networking, and two, move your data. And the other nice thing is once that's done, assuming that this is infrastructure that we don't want to retire, we can simply re-image this and now join this in. And we've now extended our capacity for our DBAS platform. So we can consume on demand our existing legacy infrastructure and bind that into the new ones simply because of the way that we've started to look at this problem. When we start talking about patching and upgrades, because they're images and because that's where most of this information is coming from, we can actually just run a nightly build. We build out new versions of the images. We're pulling in the latest updates to the operating system. We're pulling in new updates to tools. We're updating the minor versions on MySQL. These get deployed out to our data plane hosts in our development environment, and we have a set of tests and monitors that are actually running and looking at all of this infrastructure. And so we can run a variety of tests, run through existing cases that we've seen, and make sure that there's going to be no impact. Once we've validated all of that and our team is comfortable, we can start promoting that through our environments so that that image starts going up and making its way into production. And once it's up in production, the exact same mechanism actually brings that down into our data plane hosts. So now we've got the latest upgrades for minor versions, we've got security patches, and we've got a consistent pattern for getting that out. It still leaves us with upgrades. So what do I do when you want to say move from 5.6 to 5.7? How would that work if we take this assumption? Well, from 5.6, I can do the same thing that I would do anywhere else. I can take a backup. I can go ahead and create a new 5.7 image somewhere else within our infrastructure. I can pull that information down from your master that was 5.6, and I can run either an in-place upgrade or a MySQL dump depending on what I need to do. This is all very standard. This is what you would do manually anyway. We can actually automate this very quickly in our system. Once that's in place, we can do the same thing. We can actually slave this into our masters. Now, we would make one differentiation here in that This wouldn't be seen by our system as a normal slave because we don't just want to fail over to this until we're ready. We want to be able to actually test this out and make sure that everything's working, so we do make some distinction there. But once we're comfortable with it, everybody's ready to go, we take one more backup of the master, because this is a point of no return, and then we can fail you over. So from a user's perspective, we've kept pretty much 100% uptime. We've done an in-place upgrade, and we've done that all through just a very simple process because we're able to abuse data locality and our network routing. So when we're building up our service, we said we didn't want to just necessarily automate something that was complex. That can be problematic. It's not that it doesn't work, it's just I like having things that are simple and repeatable. And so when we were building up the internals of our services themselves, we tried to mirror everything that we were doing off of what you would do from a normal DevOps kind of life cycle. And so we build this complexity by building off of previous things. And so we start off with a very simple layer. I've got some backups that I want to take. I know how to do a restore. I can create a new container. I can tear one down. And I can tell my routing service to just redirect traffic from one place to another. That's great. That's a really easy set of capabilities. I can test them. They're very easy to understand. So when we want to start building complexity, it turns out that we can actually look at a lot of the things that we want to do as building blocks. So for some things like failing over a slave, there's some additional work. You can't just reroute the traffic. You may have to notify that slave that it's now the master and do some additional work in there. But generally speaking, you're building off of the previous functionality. Same thing with creating a slave in and of itself. That's really nothing more than taking a backup from the master so that I've got some of the latest bits. That is creating a new instance with the correct sizes, and then that's just restoring the data in and issuing some commands to tell that slave where its master is at. So I can still build off of that. And we can even get some things that are really complicated, like moving an instance. That's something that would actually be frightening if you thought about actually trying to do that. But because we're building off of a lot of these really common building blocks, we can actually achieve something that is very complicated with testable, repeatable pieces of our system. And the things that make sense to any operator that's coming up here. You don't have to know a whole lot about service development, any of the rest of the stuff. These are just normal, common tasks that you would do. So that alleviates a lot of the problems that we have around some of the knowledge gaps. And moving an instance, there's a lot of reasons why you might want to do that. Some ones that you might not think about necessarily are, resizing. I can actually now dynamically give you more allocation. I might find that with where you're placed right now within our infrastructure, you're not necessarily getting the best network experience. Because of where your users are coming in, I can actually move you to get your data closer. So we can actually do things to improve performance of our system as a whole this way. Being able to move things around is something that has been really beneficial to us. And so when we're talking about some of this stuff, some of the gains that we've seen, this allows us to do some things that we weren't able to before. So for instance, we can have a bunch of remediators that sit here and they're looking at information from the services themselves, from the routing layer, they're looking at the host, they're looking at our persistence, they're looking at the metrics that we're generating. And we can actually have that start making decisions for us and start alleviating some of the tasks that we might commonly have to do. This can actually handle things like, hey, this host has got too many people allocated to it, we need to alleviate some of that pressure. It can actually just use our DevOps APIs and the information that it's getting to rebalance this stuff for us. And this frees us up as operators to start doing some more of the engagement that we'd like to with our customers, and then building out new functionality in our system instead of just focusing on keeping the lights on and hoping that we don't have any issues. This also allows us to focus on the business needs and build the intelligence here. Because, again, we're building off of a lot of those common subsystems and those common tasks. And so as long as we're able to break things down, this becomes a really nice piece for us. And so some of the things that we've seen is, from a user perspective, before, whenever you requested capacity, you'd have to put in a ticket. It would take some time for that ticket to get exposed. Right now, we've gone from an average of about 2 weeks down to in the system, I can provision you new capacity anywhere that you want within about 15 seconds. And that's from the time that you make the request to the time that you can actually connect in and start using that instance. I'd make an argument that's a pretty nice piece to have. One of the other things, we don't have to look at this as a complicated environment anymore. We've actually started to build out a lot of metrics and dashboards for starting to take a look at our environment. I can actually watch the individual nodes that we've got communicating back and forth across our network in real time because of the way that we've built this up. So we have a lot more visibility into our system than we did before. We've also been testing some fun stuff out with that remediator service. Some of the first places we were looking at is just capacity, but we've now started to do things like inject network failures so that you can't actually connect to a master to make sure that our remediators can detect that and do fast failovers for our user. And then we've also been working with testing out this idea of doing the rapid patches. And we've been doing this for several months now on actually a daily cycle of pushing in, and we have yet to see any issues. Now that doesn't mean that we're not going to at some point in time in our production environment, but it is a really nice piece for looking at everything going forward. We're very confident that this is going to work. And so we've spent this time looking at everything to try and figure out how to solve the problem, but also what the problem actually was for us to be able to kind of grow out. And so since I've only got a minute left, I'll go ahead and stop here. I want to thank everybody for coming. This has been awesome for me to be up here talking. I'm trying not to smile this whole time. And I hope you guys have a fantastic rest of the conference. And again, I will be outside afterwards, and you guys can catch me in the evening if you have any questions. Thank you.